Alright, in this video we'll go on to problem number 13 through 15. So in 13 we have a composition that is nested 3 deep there. So your outermost function is something squared. The middle function is sine of something, and the inside function is 2 theta. So how are we going to do this? F prime of theta will be equal to f prime of theta is equal to 2 times 1/4, then sine to the first power of 2 theta. So we've done one level of chain rule here. We took the derivative of the outside function, leave the inside alone. Now we need to multiply that, and that's to the first power there. That's not a prime. And we can put parentheses around the 2 theta. The second thing that we're going to do is take the derivative of the middle function, which is sine. The derivative of sine is cosine, and we'll leave the inside function alone. Then we're going to take the derivative of the inside function being 2 theta, and its derivative is 2. So all we need to do now is to simplify this, and we end up with 1/2 times 2. 2 times 1/4 is 1/2 times 2 is all 1. All of that cancels out, and we end up with simply sine of 2 theta times the cosine of 2 theta. And that's good enough for that one. H prime of t. Find h prime of t when h of t is 2 times cotangent squared of pi plus 2. So in the above question, I don't have parentheses there. It's probably safe to have that. In this problem 14, we do have parentheses. So again, the outsidemost function is something squared. So h prime of t will be 2 times the 2 that's there already. Then cotangent, reduce the power to 1, and pi t plus 2. So we've done the outermost layer of the chain rule. Then we go to the middle layer, which is cotangent. The derivative of cotangent is negative cosecant squared of, leave its inside alone, pi t plus 2. Next, we need the derivative of pi t plus 2, which is just pi. So if we simplify all that, we get 4 pi cotangent, not cosine, 4 pi of cotangent pi t plus 2. We'll bring out that negative sign times the cosecant squared of pi t plus 2, and that does it for this one. So number 14, number 15, and 13, 14, and we'll go on to 15 now. With 15, we have implicit differentiation here. And so we'll need to find the derivative implicitly, and that would be, we'd find that by taking the derivative of both sides with respect to x, Now, again, we're looking for this at the point 8, 1, so we don't have to do all the simplifying here. We can plug in and get our value much sooner. So, derivative of x to the 2/3 is 2/3 x to the negative 1/3. Derivative of y to the 2/3 is 2/3 y to the negative 1/3 times y prime, and that's all equal to 0. So if we wanted to here, we could start plugging in x is equal to 8, y is equal to 1. So 2/3 cube root of 8. 2 over 3 times the cube root of 8. And cube root of 8 is 2, so 2 over 6 is 1/3. Then for y, it's 1, and we get 2 over 3 times the cube root of 1. Cube root of 1 is 1, so that's simply 2/3 there. Y prime. We can't add those two together. But at this point, we can subtract the 1/3 across. 2/3 y prime equals negative 1/3. Multiply both sides by 2 over 3, or sorry, by 3 over 2. And we end up with y prime is equal to negative 1/2. So remember that you don't have to simplify everything down when you are looking for the derivative at a particular point. You can do your differentiation and then just start plugging things in and simplify. It might make it a lot simpler for you to do it that way. And we'll stop this video here and go on to problem 16 in the next video.